In this particular chapter, we're most interested in working with series actually, okay, before we learned about sequences. So sequences are a list of numbers. So this would be a sequence, 1, 2, 3, 4, 5, etc. A series is when you add the numbers, 1 plus 2 plus 3 plus 4. And what we're most interested in is infinite series, so a series that goes on forever. And just for a simplistic sake, we'll just call it a series. But we're always talking about infinite series. But in order to figure out what happens to a series, we also need to understand sequences too. Okay? And what we're most interested in is knowing if a series, so if I add up a bunch of numbers infinitely, does it actually equal a value, a sum, or does it not? If it actually equals a value, we say it converges. If it doesn't equal a sum, we say it diverges. Now, in order to figure out what's happening, though, we need to actually understand sequences as well. But let's talk about just some notation. So if you remember, this is sigma. It's a Greek letter of the alphabet. So this is a way to write shorthand addition of a bunch of terms. So this is called your lower index. This is called your upper index, and it's basically a counter. So this one is saying count from 1 to infinity. So we're going to count from 1, 2, 3, etc. And this is your general term. So our first term is going to be a sub 1. We just plug in 1 for n. Then we just increase the counter by the next number. So your second term is called a sub 2. So we're going to add this infinitely. So this is sigma notation. This is called expanded notation. Okay, to figure out what's happening to a series, we're going to look at what's called the partial sums. So the first partial sum, called S sub 1, would be just the first term, A sub 1. Done. Your second partial sum, S sub 2, would be just the sum of the first two terms. Your third partial sum would be the sum of the first three terms, etc. Okay. And what we know is that if the sequence of partial sums converge, then the series is said to converge. Okay, let me show you an example to show you what this means. So let's say we're looking at this series, 1 over 2 to the n, and we need to know, does this series converge or not? Okay, so basically, if I write this out, this would be 1/2 to the first, plus 1 over 2 squared, plus 1 over 2 to the third, plus etc. And we're trying to figure out if I add these numbers up infinitely, is it going to add up to a value? So the way we're going to do this, I'm going to look at the partial sums. So my first partial sum would just be 1/2, first term. Your second partial sum will be the sum of the first two terms, which is 1/2 plus, and the second number is 1/4. And if I add these together, I get to 3/4. The third partial sum would be 1/2 plus 1/4, and then I need to include this number, which is 1/8. And if you add those together, it's 7/8. And I'll do one more. So the pattern continues. So your fourth partial sum is going to add on 1 over 16. And if you do this, you get 15 over 16. And we could do this forever. But what I'm going to do is I'm going to look at the list at the sequence of partial sums. So the sequence is a list of numbers. So if I look at the sequence of partial sums, it's 1/2, 3/4, 7/8, 5/16. And it goes on forever, but it kind of appears, 15/16. It appears if the numbers are getting closer and closer to 1. So maybe this sum here is 1. We're not sure, but it kind of appears that way. So looking at the sequences of the partial sums is a way to tell whether the series converges. That's what this statement is saying. Okay, we're going to figure out some more ways to tell for sure whether the series converges or not, but we're just looking at that sequence just to kind of make a conjecture. Okay, let's look at two other series. Okay, so this is the series. So this is really 1/3 plus 1 over 3 squared plus 1 over 3 cubed, etc. So let's look at the sequence of partial sums here. First partial sum, second partial sum, and I'm going to go ahead and add those together. Third partial sum, and if you add those, you get 13 over 27, and I just did this on the calculator real quick, but that would be your fourth partial sum, etc. I'm going to give you one more number. So let's look at the sequence of the partial sums here. So that would be these numbers, right? Okay, It looks like maybe this is approaching 1/2, but again, not really sure, okay? So maybe it converges to a number, maybe it diverges, we're not sure. Okay, last one here. Let's look at this one. This is really 1 plus 1 plus 1 plus 1, right? It's just 1 every single time. So your first partial sum is 1, second one is 2, right? Etc. So you hopefully see the pattern here. So look at your sequence of partial sums. Now notice these numbers are not approaching any number, they're just going to get bigger and bigger. So for this one, we can definitely say if you add 1 plus 1 infinitely, this is going to diverge. It's never going to approach a value, right? The numbers are getting bigger and bigger every single time, okay? So again, the idea that a series converges if the sequence of the partial sums converge. If the sequence of the partial sums does not converge, we say that it diverges.